Your character moves, but it does not feel alive yet. Today we'll start fixing that. In this video, you will set up animation in Unreal the right way with C++. We will create a custom animation instance class, initialize and update the animation variables from C++, and then link an animation blueprint to the class and assign it to the character blueprint so everything works together in a game. Clear steps and clean code. The episode is part of a mini-series to explain how to create animations in Unreal and C++, but it is also part of Ludoria series, a video game we're building in public. You have full access to the code and the rest of the project in the description. I am Tony Munoz and this is the Game Creator Accelerator channel. Like, subscribe, comment, share, and ring the bell so you do not miss the next lessons. I do what I do because I love the video game creation process and I believe you can enjoy the same experience. If you do not know where to start, visit woolon.com, learn more about my mentorship program, and then click the link in the description to have a Zoom chat with me to figure out how it can help you. Now, let's continue. First off, let's present where we left the last time. The last time we have a character that we can dominate, that we can handle with the keyboard and is jumping. But as you can see, is very static and boring. So we're going to start today working on the animation process of this character. First step is go to the classes folder in our project, right click, select new class, look for all classes, and in the search, look for AnimInstance. Pick the one that is named AnimInstance. Click Next. Let's name it Player AnimInstance and create class. In the Visual Studio, you might find this prompt. Select the option of Reload All. And let's open the header file. Alright creators, before we start adding any animation logic, we need a place where we can prepare everything for our animation blueprint, a kind of initial setup zone. For that, we are going to use the next function, virtual void NativeInitializeAnimation override. Think of this function like the begin play of the animation blueprint. Here we usually get a reference to our character or our pawn, the one that owns the animation. In that way, we can later read things like the character speed, jumping state, or if they are aiming and send that data into our animation graph. In short, it runs once when the animation begins, is where we prepare references, and it helps prevent crashes later when our animation tries to access data from the character. Without this setup, your animation graph wouldn't know who it's animating. The next steps is about updating properties of the animation. For that, we're going to create a void function named UpdateAnimProperties. And because this is going to be consistently updating, I'm going to pass a delta time. And I want this function to be available not only on C++ but also in Unreal. To do so, before the void declaration, we'll add ufunction blueprint callable. Let's save. I'm going to increase the zoom for this. Now we are telling Unreal, hey, make this C++ function available inside blueprints. So designers or you can call it visually. Now let's create the definition in the implementation file. Move the mouse over, click here, and create definition. Let's go back to the update as well, and create definition. Go back to the header file, and now we are going to declare some variables. Let's open a private section and start with uProperty, Transient, visible anywhere, blueprint, read only. The category, let's name this one, for the moment at least, player. And meta, allow private access equals true. And now I'm going to make a new change. Instead of forward declaration, we're using a new way of presenting variables recommended by Unreal, which will be T object ptr is shooter character and initialize on null pointer. In other classes and previously in Unreal, for example in the shooter character, we did this forward declaration. But based on my most recent research, I found that Unreal is recommending to use this new notation. But of course, because I don't have the shooter character, I have to forward declare it at the top of the function. So here, let's add a shooter character and the error disappears. In the U property, we have a new property specifier named Transient. Transient just means this value only lives at runtime. Unreal won't save it into assets or levels, and it won't load it from disk. We create it when the game starts. Use it while the game is running, and that's it. Think of it like a whiteboard note during class. You write it, use it, and erase it when class ends. It's perfect for catch pointers like the movement components or owning characters because those are easy to grab again every time the game starts. Then we use the T-object pointer in Unreal Engine 5 because it is the safe, future-proof way to point to U objects. It works with Unreal's garbage collector, survives potential object moves, and adds editor safety checks, all with basically the cost of a normal pointer. Same syntax, more protection. Now let's create the other variables. Another T-object pointer, in this case a U character movement component, and let's name it moveComp and initialize on null pointer. We apply the same process that we did a moment ago for shooter character, but in this case will be U character movement component. And this property will be declared U property transient. Just that. Because we have the U property, we are telling that we're going to use the reflection system and the garbage collection. Using the transient means that we are not going to save on disk, only for runtime. And because we didn't add the rest of the parameters, it is not automatically visible in the editor or the blueprints. Now let's go to the other parameters. The next one is a boolean named b is in error. I will initialize with false. Another boolean, b is accelerating, false as well, and a float named speed that will start with 0, 0. Type float. The U property for these three will be the same, so let's declare it. Visible anywhere, blueprint read-only, category player, meta, allow, private access, true. Copy and use it here and here. And now let's add some comments. Character using the animation, movement component of character using the animation says if the character is in the air because it's jumping or falling. It is indicating that the character is changing the speed, and this one will be the movement speed of the character. I forgot one extra parameter, which is another boolean named b is moving, which will start also with false. Copy the property. It is indicating that the character is moving. Speed different to 0. And save. Summarizing these parameters, first we have the shooter character that will give us access to the player character, where we're going to control the animations. We have also access to the character movement component, and then we have some properties that will help me change the animation based on their values, like it is in the air, it is accelerating, it is moving, and the speed. Let me take you away for a second. You're probably watching this because you are trying to achieve your dream in the gaming industry. I know how that feels. At 40, I decided to move into this industry and I made a lot of mistakes before I got it right. I chose this path because we get only one ticket in life. I want to build something with legacy that helps me connect with others and feeds my creative spirit. If you feel the same, visit woolon.com and learn more about the Game Creator Accelerator. Then let's have a one-on-one chat to figure out how the program can help you become a more inspiring version of yourself. What are you waiting for? The link is in the description. Now let's continue. It is time to go back to the implementation and let's begin with the initialization. First, we're going to call super native initialize animation, and then I'll try to get the pawn from the game, and from that collect the shooter character and the movement component. So let's start with if a pawn, player pawn, is equal to try get pawn owner, and if we can get the pawn owner, then the shooter character will be equal to, I'm going to make a cast of a shooter character of the player pawn. And for the movement component, define it like move comp, will be shooter character. And depending on the value of shooter character, I can say shooter character get character movement or null pointer. And because I am using the shooter character, I have to include shooter character H. So in the native initialize animation, we're first checking that we have a player pawn. If we have the player pawn, then I want to cast it as a shooter character, which will be assigned to shooter character. And if I have the shooter character already assigned, then I know that the shooter character has a character movement component. And then I'll assign the movement component to this parameter. And if I can collect the shooter character as a cast, then the movement component will continue being a null pointer. Once we have the initialization set, let's start with the animation parameters that will update every frame. Let's start with confirming that we have the shooter character and the move component. What I'm doing is, if one of these parameters is not set, then return. That's why we use the exclamation at the beginning. I'm saying that if it is not set or this one is not set, then return. If we continue, it's because all these parameters are set. So let's start playing with the rest. First, I'm going to define a const f vector named vel for velocity that I will get from the shooter character get velocity. And as speed is vel dot size d. Why is that? Because I don't need the z component to get the speed. That's why I transform it into a size 2d. We can add a comment like I don't need the component on z to get the speed. Next is in the air. B is in air. This is the parameter we create. Move component, and we have the method is fallen that will provide us with a boolean telling us if the object is in the air. Now the move component requires also an include, which is the game framework character movement component. No more errors. And now, is the player actively providing movement input? And this is important because sometimes we misunderstand the concept of accelerating. And bear with me just for a second. Let's define B is accelerating equal to move component get current acceleration size squared. And I'm going to compare this to something that is very small. And for that, we have a parameter set in Unreal, which is kinda small number. Kinda of a small number. Imagine that it's a number that is very, very close to zero, not zero. But because sometimes you can't play with the condition of exactly zero, that's why we use this number. You can put 0.0, but this will guarantee you that you will not generate bugs or errors because you didn't reach the point 0.0. Now look that at the top I said that is the player actively providing movement input. That is because the get current acceleration from the movement component is not really saying that the character is accelerating. This is asking the engine if the player is still pressing some key. And this is confusing because when we talk in terms of physics, acceleration is the change or variation of a speed. But in the context of Unreal, when we use get current acceleration, it's not the variation of a speed. It is confirming if the character is providing, if the player is actively doing something with the input. For example, keeping the W key down. In other words, velocity tells us how fast the character is moving, but acceleration tells us if the player is actually pushing a key or not. So when I release the key and the character slides for a second, I don't want the animation keep showing run. I want it to start blending back to the idle state. That is why Unreal gives us the get current acceleration. It's like asking the engine, is the player still pressing something or are we just coasting? Now, let me get back for a second to the top of this function. What happens if the shooter character or move component are null? If that's the case, we need to recache them. This also applies if the player changes character. You need to go back and check who is the current pawn for this player. So let's make sure that we will be able to recache them. First, we start with, again, a pawn. Let's call them owner now. Try get pawn owner. If owner now is not equal to shooter character or not is valid, move comp, then I think we can copy this back here and change the owner now on this parameter. This is a good practice when you change characters in a video game. And I'd really recommend you to not only confirm that you already initialized the shooter character and move component, but also that if you didn't do it, can I find another pawn and another shooter character and another move component to continue playing my game and not get stuck? This is the way.
This is the way.
Let's save this and go back to Unreal. Inside Unreal, compile. I'm going to make some rearrangements in our project. I will create inside games a folder called characters, and inside that one called main character. I'm going to take the blueprint and add it into that folder. Move here. Now inside the folder for my character, I want to add an animation blueprint, the first step about creating animations inside Unreal. Right-click and select Animation Blueprint. Or you can also select Animation Blueprint. Look for the skeleton of the character that we are using. The base character BP uses this skeleton. Select it. And in parent class anims, you are going to use the one we created, which was named player AnimInstance. Remember that this was the name we assigned it when we created our class. Selected both of them and then create. For the name, we're going to use shooter base anim BP. And in fact, I want to rename my character blueprint. So right click, rename, and I want to name it shooter base character BP. Compile to check that everything will be okay. Test. Good. Now let's open first our blueprint class. Select Open Full Blueprint Editor. Let's check our character. To the right in the details, you have an option named Animation. Be sure that you select Use Animation Blueprint, and in the Animation class, you can click here and look for the animation that the blueprint that we just created, which is the shooter base anim BP. Compile and save. Now we are telling this blueprint that it will use the animation blueprint that we created a moment ago. Let's open our animation blueprint. When you open an animation blueprint, you have these two tabs, which are the EventGraph and the AnimGraph. You can access, if you close one of them, here on the EventGraph or the AnimGraph. Let's talk about first the EventGraph. This is the logic side of the animation blueprint. Here it runs every frame to read information from the character and the world, then stores that information into variables. Think of it as a data prep room. It does things like give the characters a speed, check if they are in the air, read aim direction, and set booleans or floats of any kind. The event graph does not build a pose. It only prepares the numbers the animation system will use. Now let's go to the Anim Graph. This is the pose side of the animation blueprint. It takes the variables prepared by the event graph and uses them to pick and blend animations. State machines, blend spaces, aim offsets, layer blends, and montages all live here. The Anim Graph's job is to output the final pose that goes to the mesh each frame. It does not fetch gameplay info. It consumes the variables and turns it into motion. Simple contrast, Event Graph makes the data. Anim Graph makes the pose. Together they keep the logic and your animation blending clean and easy to debug. When you create an animation blueprint, you will find in this section, which is the class setting, that the parent class should be the class that you set. Remember that we call our class player AnimInstance. This is our class, even though they are separated here because the uppercase, this is the class that we are using for this animation blueprint. And because that is our parent class, we can call the methods that we define in C++. Let's go back to the event graph, right-click, and look for UpdateAnimProperties. Here is the method that we create. If you can find the method, you can change this context sensitive. Now, even if you change the context sensitive, you can't find the method, then check that the class setting corresponds to the class that you defined. I'm going to take this method, and now I will connect it with the event blueprint update animation because I want this method to be called each frame. From here to here, and the delta time that we set will be connected to this delta time. Now you can compile and save. To summarize what we did, first we created a class of the type animation instance. In that class, we set some parameters, including the shooter character at the movement component, and we create two functions, one to initialize the animation and the other to update the animation as time progresses. Then we create a blueprint for this animation blueprint and assign it to our shooter-based character blueprint. Inside the shooter-based animation, we confirm that the class setting is the one we created And then we connect the event blueprint UpdateAnimation with our method defined in C++ as UpdateAnimProperties. That is it for this lesson. We built the animation instance, wired the variables in C++, and link the animation blueprint to our character so everything runs in-game. In the next lessons, we will keep leveling up your animation system step by step. Remember, the full Ludoria project is open. Try it and tell me what you're planning to create. Show your support for this channel. Like, subscribe, comment, share it with a friend, and ring the bell so you don't miss the next technical episode and the strategies to build a successful career in video games. And stop being frustrated about not knowing where to start. Let's have a chat. Visit woolon.com, learn more about the Game Creator Accelerator, and start moving forward. You have only one life. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.